Hi and welcome to Show Cells classes. Today we are going to be doing rules of differentiation and its usage in comparative statics. This is usually the portion that is very easy, but students usually find it very difficult to deal with. Let's begin. We are given a question out here. We are given total cost function C equals to Q3 minus 5Q square plus 12Q plus 75. We need to write out the variable cost function. The variable cost Vc is nothing but the part of the function which consists of the variables, that is Vc equals to q cube minus 5Q square plus 12Q. Now we need to find the derivative of the Vc function and interpret the economic meaning. That is dVc by dq equals to 3Q square minus 10Q plus 12. We need to interpret the economic meaning of the derivative. This is nothing but the marginal cost function. Moving on to the next question. Over here we are given an average cost function AC equals to Q square minus 4Q plus 174. We need to find the marginal cost function, and then if the given function is more appropriate as the long run or short run function, we need to figure out that. Let's continue. Now we obtain the cost function. The cost function is nothing but C equals to AC into Q. That is, we get Q cube minus 4Q square plus 174Q. Now we need to find the marginal cost function. MC is dq dc by dq, which is equals to 3Q square minus 8Q plus 174. Now notice in the total cost function there is no fixed cost, that is 0 fixed cost. Thus the situation depicted here is the long run, because if you remember, in the long run the fixed cost is always 0. Now we have a question that it seems long but is a very easy, and you will get this kind of questions always. This is very easy and it can be scored easily. We are given an average revenue function, that is AR equals to 60 minus 3Q. We need to plot the average revenue curve and then find the marginal revenue curve. Well, I'll leave that to you because I'll go on move to the sums. Maybe later on I'll display the graphs to you. We'll start off with question number B. We need to find the total revenue function and the marginal revenue function mathematically from the given AR function. The total revenue function TR is nothing but AR into Q, which is equals to 60Q minus 3Q square, and the marginal revenue curve is derivative of the total revenue curve DTR by DQ, which comes to 60 minus 6Q. Now let's see what the third part says. Does the graphically derived MR curve in A check with the mathematically derived MR curve in B? It should. If you have done the graphic correctly from the first one, it should always check with the mathematically derived MR curve. Let's do D. Before moving on, I'd like to say Remember this, if you have a question where you have derived it graphically, you can always check your answer mathematically. In this way, you can always be certain that your answer and the graph that you have done is accurate. This ensures that you don't lose out on marks or in any other ways can make an error that might be not rewarded. Lastly, we need to compare the AR and MR function and about their relative slopes. The AR curve that we have been given is AR equals to 60 minus 3q and MR equals to 60 minus 6q. Notice that the slope of MR is twice the slope of the AR curve. This is how you will normally get questions in your exams or any other competitives that you give. Next, we'll do a very easy question. We need to find the marginal and average function of the following total functions and to graph the results. First, we are given C equals to 3q square plus 7q plus 12. Now, MC or marginal cost equals to d of total cost function by dq, which comes to 6q plus 7. The average cost is nothing but the total cost divided by q, which is equals to 3q plus 7 plus 12 by q. Similarly, we will be doing it for the revenue function. Now, we are given a revenue function r equals to 10q minus q square. Let's find the marginal revenue function. Again, we'll just differentiate the revenue function d tr by dq, which comes to 10 minus 2q. Similarly, average revenue is nothing but the total revenue divided by q or quantity, and it comes to 10 minus q. Again, we'll be doing it for a little tough function, that is the total product function. Let's see. I'll be clearing the screen, so don't worry. Now, in the third function, notice that it's given in terms of L or labor. That is, this is our total product function. So let this equals to TP. Now, to find the marginal product, we will simply differentiate with respect to L. Therefore, dTP by dL equals to A plus 2BL minus CL square. For the average product equals to TP by L, which equals to A plus BL minus CL square. That is, we just divided this function with L. Now we'll do a slightly different kind of sums. We are given a production function q equals to 0.96 k to the power 0.3 and L to the power 0.7. We need to find MPPK and MPPL functions, and we need to find is MPPK a function of k alone or of both k and L, and what about MPPL. Let's do this. MPPK equals to 0.3. That is, MPPK equals to 0.3 into 96 k to power minus 0.7 and L to power 0.7. This is simply derived by differentiating this function of q with respect to k. Now let's do the same for MPPL. Over there, we will just do dq by dl. Let's see what it comes. Now you see that the MPPL is equals to 0.796 k to the power 0.3 L to the power minus 0.3. Over here we see it's written whether MPPK and MPPL are independent of K or L or not. We see that both K and L are present in both the terms. So MPPK and MPPL is not a function of K alone. It consists of both K and L. Moving on to the next question. Now we are given a utility function u equals to u x1 x2, that is x1 plus 2 whole square and x2 plus 3 whole cube. Now we need to find the marginal utility function of each of these two commodities. You can pause the video because I'm gonna be solving it within just a second. Yes, it's that easy. Please try it out. For the first commodity, we just differentiate with respect to x1. Thus, we get u1 equals to 2 into x1 plus 2 into x2 plus 3 whole cube. Similarly, u2 equals to 3 into x1 plus 2 whole square and x2 plus 3 whole square. We differentiated with respect to x2. Let's do number B. Now we need to find the value of the marginal utility of the first commodity when 3 units of each commodities are consumed. That is, we will put u 3,3 for u1. Therefore, u1 3,3 equals to 2 into 3 plus 2 into 3 plus 3 whole cube, which comes to 2160. In the next, we'll be doing further sums, so stay tuned for our future videos.